November 2003, the coast of southwestern Australia. A 9-foot female great white shark, healthy, strong, tagged 4 months earlier by a team of marine researchers as part of a migration tracking program.
I got hit really very, very hard. I had caught a glimpse of what had just thrown me that far, and it was a great white shark.
He found himself being hunted by a great white shark, and he caught it all on camera. Check it.
Is swimming normally through the cold waters off the continental shelf near Bremer Bay. Her satellite tag is recording everything: depth, temperature, speed, movement patterns. 4 months of clean, consistent data. A textbook great white doing exactly what great whites do. And then, in the space of seconds, the data goes insane. The tag records a sudden, violent plunge. The shark drops from her cruising depth to 1,903 feet, almost 600 meters, straight down at speed, and simultaneously the ambient temperature surrounding the tag spikes. It jumps from 46 degrees Fahrenheit to 78 degrees, a 32-degree surge. In the deep ocean, where temperatures decrease with depth, that kind of spike is physically impossible, unless the tag is no longer in the ocean, unless it's inside something else, inside the digestive system of another living animal. For the next 8 days, the tag records a temperature and movement pattern consistent with being carried inside a large, warm-bodied predator. The creature surfaces and dives repeatedly, moving between the surface and roughly 300 feet, a pattern consistent with an air-breathing animal or a large, active predator hunting in the upper water column. Then, on the 8th day, the tag is expelled. It washes ashore on an Australian beach, 2.5 miles from where the shark was originally tagged. The shark, designated Shark Alpha, is gone, eaten. A 9-foot great white shark, one of the most powerful predators in the ocean, swallowed by something that the tracking data said was larger, faster, and higher on the food chain than an animal most people assume sits at the very top. Filmmaker Dave Riggs, who had been hired to document the tagging project, told the cameras what everyone was thinking. When I was first told about the data that came back from the tag, I was absolutely blown away. It was obviously eaten, but what's going to eat a shark that big? John McCosker, a senior scientist at the California Academy of Sciences, confirmed the physics. That tag was 30 degrees warmer than the water in which it was swimming. The only explanation was that the tag and the shark it was attached to had been consumed by another animal. The story went viral when it resurfaced a decade later through the Smithsonian Channel documentary, Hunt for the Super Predator. The internet erupted with speculation. Megalodon, giant squid, unknown deep-sea monsters. The phrase super predator became a global trending topic. CNN ran the headline that Australian researchers are hunting for a mystery sea monster that devoured a 9-foot great white. But here's the thing, the researchers actually figured out what did it, and the answer, while less dramatic than a prehistoric megashark rising from the abyss, is in many ways far more disturbing. Because what ate Shark Alpha wasn't something from the age of dinosaurs. It wasn't something unknown to science. It was something very well known. Something that is, right now, in the waters off every continent on Earth, doing exactly what it did to Shark Alpha. And it's doing it with a level of intelligence, precision, and ruthlessness that is forcing marine biologists to completely rethink the hierarchy of the ocean. The researchers concluded that Shark Alpha was most likely killed and consumed by a colossal cannibal great white shark. Based on the tracking data, the predator would have been roughly 16 feet long and weighed more than 2 tons, a great white eating another great white. Cannibalism among the ocean's most famous apex predator. That explanation satisfied some, but not everyone. Critics pointed out inconsistencies. The temperature of 78 degrees Fahrenheit recorded by the tag was lower than the expected internal body temperature of a killer whale, which runs around 100 degrees, seemingly ruling out orcas. But it was also lower than what you'd expect inside another great white's stomach, which typically maintains a core temperature of around 79 to 82 degrees. And the post-feeding movement pattern, surfacing and diving between the surface and 300 feet for 8 consecutive days, looked more like the behavior of an air-breathing mammal than a fish. Great whites don't need to surface to breathe. Orcas do. And then there was the dive itself. Before the temperature spike, the data showed that Shark Alpha dove to nearly 2,000 feet at high speed. That's a panic response, a flight reflex. She was running from something. And whatever chased her ran her down from the surface to nearly 600 meters before catching her. The mystery of what exactly ate Shark Alpha has never been fully closed. But what the case blew wide open was a question that marine biology is still grappling with today. A question that, in the years since, has been answered with increasing and terrifying clarity. The great white shark is not the apex predator of the ocean. It never was. And the evidence that has accumulated since 2003, from South Africa to Australia to Mexico, hasn't just dethroned the great white. It has revealed that the real apex predator of the ocean hunts great whites the way great whites hunt seals, with strategy, with coordination, with surgical precision, and with a level of intelligence that borders on something most scientists are reluctant to call what it actually is. Let's go to South Africa, because what happened there changed everything. Starting around 2015, great white sharks began disappearing from the waters around Gansbaai, a coastal town east of Cape Town that for decades had been one of the premier great white aggregation sites on the planet. Shark cage diving operators, who had reliably encountered great whites on every trip, began coming back empty. By 2018, oceanographers found almost no traces of the species in the region. The sharks had simply vanished. Nobody could explain it. Overfishing was a possibility. Pollution, climate shifts. But the timeline was too sudden. Great whites don't abandon a decades-long aggregation site overnight. Something had scared them away. And then the bodies started washing ashore. Great white carcasses, large ones found on beaches around Gansbaai and later Mossel Bay. Each one in the same condition. Intact body. No signs of net entanglement. No boat strikes, but with a single clean tear in the pectoral region, and their livers were gone, surgically removed, every other organ untouched. Just the liver, the largest, most energy-dense organ in a shark's body, a massive oil-rich slab that can constitute up to a quarter of the animal's body weight, extracted through a wound so precise it looked like it had been made with a scalpel. The killers were identified. 2 male orcas, easily recognizable because their dorsal fins were collapsed in opposite directions. One bent to port, one bent to starboard. The researchers named them Port and Starboard. David Hurwitz, a whale-watching tour operator, was the first person to witness the pair in action. He saw 2 orcas hunting as a pair, not in the large pods that killer whales typically operate in. Target: a great white shark. They didn't eat the whole animal. They killed it for one organ, the liver. They extracted it and left the rest of the carcass floating. Dr. Alison Towner, a shark biologist at Rhodes University who had studied great whites in South Africa for 17 years, documented the phenomenon in a series of studies. She confirmed that Port and Starboard had been hunting and killing great white sharks since at least 2017, and the result was catastrophic. Great whites, animals that have dominated the ocean's food chain for 16 million years, were so terrified of these 2 orcas that they fled the entire coastline, not for a season, for years. Simon Elwin, a marine mammal researcher, put it starkly. 20 years of stability, and then 2 killer whales appeared, and boom, all hell breaks loose. And then it got worse, because Port and Starboard weren't just hunting, they were teaching. In August 2022, scientists captured aerial drone footage showing 5 orcas working together to kill a great white, extract its liver, and share it among the group. 5, not the original pair. Other orcas had learned the technique. The behavior was spreading. It was being transmitted culturally, passed from individual to individual, from pair to pod, exactly the way complex hunting strategies are transmitted in species with advanced social learning. And then, in June 2023 in Mossel Bay, Starboard did something that no scientist had ever documented. He killed a great white shark alone, by himself. An 8-foot juvenile great white, incapacitated, and its liver removed in under 2 minutes. Dr. Primo Micarelli, a marine biologist who observed the attack from a research vessel, described watching Starboard parade past the boat with the bloody liver in his mouth. Towner called it a victory lap, a single orca, killing a great white shark, alone, for its liver, in 2 minutes, and then showing it off. And South Africa isn't the only place this is happening. In October 2024, researchers published footage from the Gulf of California off the coast of Mexico, showing orcas hunting juvenile great white sharks using an entirely different technique. They flipped the sharks upside down. This induces a state called tonic immobility, a natural paralysis response in sharks. When a great white is inverted, its body locks up. It can't fight. It can't swim. It just hangs there, immobilized. And the orcas know this. They've learned it. They flip the sharks deliberately, hold them upside down until they stop moving, and then open them up and eat the liver. Biologist Eric Higuera-Rivas, who captured the footage, described the behavior as a testament to orcas' advanced intelligence, strategic thinking, and sophisticated social learning. The techniques, he said, are passed down through generations within their pods. And researchers identified some of the orcas in the Gulf of California footage as the same individuals previously spotted hunting whale sharks and bull sharks in the region. They're generalists. They've developed specialized techniques for different species. Different sharks require different strategies, and the orcas know which strategy to deploy on which prey. Now, let's talk about what this actually means, because the implications go far beyond one species eating another. What's happening in the ocean right now is an ecological restructuring in real time. In South Africa, the disappearance of great whites has already triggered a cascade of ecological changes. Without great whites present, their prey species, particularly Cape fur seals, face less predation pressure. Seal populations may increase. Other shark species, like the copper shark, are already moving into the ecological niche the great whites left behind. The entire food web is shifting. 2 orcas changed the ecosystem of an entire coastline. And the liver-only feeding behavior tells a story of its own. A great white shark liver is a massive organ rich in squalene and lipids, essentially a dense calorie-packed fuel tank that gives the shark buoyancy and sustained energy for long-distance ocean crossings. An orca that knows how to extract this organ, and only this organ, is making an energy-optimal decision. It's maximizing caloric intake while minimizing effort. It's not eating everything because it doesn't need to. It's selecting the highest value target in the body, extracting it with precision, and discarding the rest. That level of decision-making, combined with the ability to innovate, to teach, to hunt alone when necessary, and to adapt techniques to different prey species, isn't just intelligence. It's culture. It's tradition. It's the kind of complex, multi-generational behavioral transmission that science historically reserved for humans, and, reluctantly, for a handful of great apes. Robert Pittman, a marine ecologist who has studied orcas for decades, told National Geographic that orcas are notably flexible and creative in their strategies to take down diverse prey. Orcas live worldwide. Different populations hunt different things. Norwegian orcas herd herring into balls using coordinated bubble walls. Antarctic orcas create synchronized waves to wash seals off ice floes. Patagonian orcas beach themselves to grab sea lion pups from the shore and teach their calves to do the same. And now, South African and Mexican orcas have independently developed surgical techniques for extracting shark livers. Each population, each technique, invented independently, taught socially, refined over generations. This isn't instinct, this is innovation. And it raises a question that most people never think to ask. If orcas are this intelligent, this adaptive, this capable of strategic planning, social teaching, and cultural transmission, then what does it say about the ocean's true power structure that we never noticed until now? The answer is that we were looking at the wrong animal. For decades, the great white shark was marketed as the ocean's ultimate predator. Jaws, Shark Week, the cultural mythology of a cold-eyed killer at the top of every marine food chain on Earth. But that mythology was always wrong. The great white was never the apex predator of the ocean. It was the most famous one. And fame and dominance are not the same thing. The orca is the largest member of the dolphin family. It has the second largest brain of any marine mammal. It lives in complex social groups with distinct dialects, hunting traditions, and cultural identities that vary from population to population. It has been observed mourning its dead, carrying deceased calves on its head for days. It cooperates across generations. It adapts to new environments faster than almost any large predator on Earth. And when it decides that great white sharks are on the menu, the great whites don't fight back. They run. Entire populations abandon coastlines they've inhabited for decades, because somewhere in the deep circuitry of a 400-million-year-old predatory brain, the great white recognizes something that took human scientists until 2017 to figure out. There is something in the water that it cannot beat. Alison Towner, the woman who has spent nearly 2 decades tracking great whites along the South African coast, watching them vanish, watching the carcasses wash up with their livers missing, watching a single orca kill one of the most feared animals on Earth in under 2 minutes, said something that should stay with you. She said great white sharks are apex predators, but orcas are smart hunters and learning all the time. Learning all the time, that's the phrase. Not hunting, not killing, learning, adapting, innovating, teaching, getting better, developing new techniques, passing them down, refining them across generations. That is what ate Shark Alpha. Not a megalodon, not a sea monster, not something from the pages of mythology, something alive, right now, in every ocean on this planet, with a brain that learns, a social structure that teaches, and a hunting efficiency so precise it can open a great white shark like a surgeon and remove a single organ in less time than it takes you to read this sentence. And it's getting better at it every year. What hunted the great white shark doesn't just change everything we know about who rules the ocean, it changes what we mean by the word predator, because the great white kills with teeth and speed and brute force. The orca kills with strategy, coordination, cultural knowledge, and a level of cognitive sophistication that makes the great white look like what it actually is in the hierarchy of the sea. Not the king, the prey.